We've got some examples here where we're going to end up having to use FOIL. So I wanted to make a new video just to have these problems on their own for students that might need to just see these problems. So remember what we said in the very beginning. Try and isolate that radical on a side all by itself if you can. So I need to get the square root of x minus 1 all by itself. So we're going to subtract 3 from both sides. That's going to give us x minus 3 on the left and then the square root of x minus 1 on the right. And we said we were going to raise both sides to the power of the index. So to undo a square root, we're going to square. So I raise both sides to the second power. Now remember that x minus 3 quantity squared is x minus 3 times x minus 3. And then the square root of x minus 1 squared is going to be x minus 1. So we're going to leave that right side just for a moment, and we're going to FOIL out the left-hand side. When I FOIL that out, I get x squared minus 3x minus another 3x plus 9 equals x minus 1. That's x squared minus 6x plus 9 equals x minus 1. I'm going to subtract x from both sides. That's going to give me x squared minus 7x, and I'm going to add 1 to both sides, which would change that 9 to a 10. Now we're going to have to factor and use our zero product property. So x squared minus 7x plus 10 factors to be x's in the first position because x times x is x squared, and then I need 2 negatives to multiply to be positive 10, but combined to be a negative 7, and that would be negative 2 and negative 5. So x minus 2, x minus 5. Now our zero product property says x minus 2 equals 0 and x minus 5 equals 0. So we have x equals 2 and x equals 5. But what have we been doing at this point for every single problem? We're throwing it back in to make sure that it works. So we're going to have a 2 and a 2 right there. So I'm going to have 2 equals the square root of 2 minus 1 plus 3. 2 equals 1 plus 3. I said 1 because 2 minus 1 is 1, and the square root of 1 is 1. Is 2 equal to 4? Is 2 equal to 4? I would say no. X equals 2 is extraneous. Okay, let's try, I'm going to do this one in orange. Let's try putting a 5 in. So I'm going to put a 5 in for both x's, and we get 5 equals the square root of 5 minus 1 plus 3. 5 equals the square root of 4 plus 3. The square root of 4 is 2, and 2 plus 3 is indeed 5. Therefore, x equals 5 is our only solution. A little bit more work in checking our solutions for this problem. True story, yes, that is true. Number 16, if you think that you can maybe give this one a try based on what we just did, I encourage you to do so. I'm going to explain it, and then I'm going to move on to a different type of problem. So this would be your only opportunity to check your understanding. So if you need to maybe do a step and then check a step, I encourage you to do that at the very least. So press pause and see if you can do that very first step. Okay, here's our first step. We're going to subtract 3 from both sides. And on the left-hand side, that's going to give us the square root of 5 minus x. And on the right-hand side, it gives us x minus 3. Now I'm ready to do the second step. The second step is to square both sides because my index is a 2. So I'm going to undo the square root by squaring. And that gives us 5 minus x on the left. And then on the right, I've got x minus 3 times x minus 3. And when I multiply that all out, I get x squared minus 6x plus 9. I'm going to add x to both sides. 5 equals x squared minus 5x plus 9. And I'm going to subtract 5. I'm bringing everything over to the right-hand side, so I set that variable, all the terms that are non-zero, on the opposite side. So x squared minus 5x plus 4. Now we're going to factor and use our zero product property. That factors to be x minus 1, x minus 4. So my two potential solutions are x equals 1 and x equals 4. I'm going to check this by throwing the 1 back in for both x's. So what that's going to give us is 3 plus the square root of 5 minus 1 equals 1. 3 plus the square root of 4 equals 1. 3 plus 2 equals 1. And that is not true. So x equals 1 is extraneous. Sometimes they're both extraneous. Sorry. Sometimes they're both extraneous. Now we're going to try 4. And we're going to put 3 plus the square root of 5 minus 4 equals 4. So 3 plus the square root of 1 equals 4. And the square root of 1 is 1. And 3 plus 1 is indeed 4. So x equals 4 is our only solution. Thanks for sticking with me. We're going to come back and we're going to do the next two problems right here, 17 and 18. Although I'm guessing that if you wanted to try those on your own, you could try them on your own and then check the video to make sure that they're right.